Now then, if I close this and do activities, did I lose it? What have I done here? Let's see if I bring it
All
up.
right, so right now it looks like you're sharing your desktop with a cool looking dude on a motorcycle.
Yeah.
Yeah, that's my son on our first motorcycle ride together.
Nice.
Okay,
Nice
so
bike.
now I got that set. Now I got to get the presentation open again because I closed a bunch of stuff to see what I was doing.
Okay.
I'm sorry, guys. I tried to do the setup earlier with just myself and I couldn't get it to do it.
Yeah, no problem. You got this.
Where's there it is. Now then, if I do slideshow, how about that? You have that now?
No,
We see your cursor and look a cool looking dude on a motorcycle.
there,
Oh, there we go.
There we go.
Okay, we got it now, huh? Okay, so this is the lessons learned from the Humanoid project, and you can see a picture of the robot just kind of loosely gathered together there on the right-hand side. And that was when I first took it out. That still has the smaller body, and it doesn't have the full axle ankle axis capability. But you can get a rough idea of the size of the robot. It's about 25 inches tall. Now, so what I'm just going to talk about today is just all the stuff I went through because it's been a miserable. I've designed a lot of stuff in the years. I was a test engineer for 3 different major test companies. I designed and built circuits of all kinds, hardware, software, wrote the programming and everything. Assembly language and about 5 or 10 other languages were used in getting those running. And this has been one of the most frustrating experiences I've ever had. I thought I'd have this done in a couple of months. I'm 6 months in and I still don't have the software running on the robot yet. So first of all, I got design lessons for hurry up people. I'm one of those people that just build stuff. And I kind of have to have it in my hands before I can do it. So I call that hurrying up the project. But in reality, it usually slows you down, as most of you probably know. Then I have some 3D printing lessons. And boy, did I have to learn some new patience to get everything to work the way I want. One of the problems is most 3D printing is not really mechanically robust. So you have to be careful about your speeds and your temperatures. And I use all PLA plus and got it to work all right. And I actually can print fairly fast, about 60 millimeters per second and 0.1 millimeter layers, and get sufficient hardware strength out of the material so that everything works. And we'll go through some of that stuff. Then the wiring lessons was, how much space did you think you needed? No, you need more than that. Then the assembly lessons, as you know, the way I designed the brackets, they snap in, and I do a lot of stuff like that. So that's why I say plastic gives, I hope. Sometimes it doesn't. And then the summary and what I think is the future of the robot that I call QB. So more planning, you have to have more space. So this is the new box, and you can see the depth above the servos there and the amount of space I have available for the wiring. So this doesn't have the head wiring in it all the way yet, but it has most of the wiring in place. And you can see that there is considerable volume there for me to run wiring in. So that was a big change. I actually had to increase the body size by almost 30% in order to have enough room to run the wires. And then there's the issue of cooling. So you have to make sure that when you have a fan on it, the fan's in the right location so the cooling takes place. So what I did was, when I enlarged the box, I changed the side that the Raspberry Pi was mounted in to also give me a little different space. And that also gave me more room for the fuse. So in order to make that room work, I have to now change where the fan was, so that required that I reprint also the cover. And then because of the depth, I had to change the support structure, which is in the cover. When the cover slides on and bolts down, it actually provides the support underneath the servo brackets over here. If you look, you know how the ears are on the sides of the servos, I have a piece that slides down in there and provides support for the servos to hold them in place. And then handling. So when I'm talking about handling, I'm talking about handling the wires. The wires are fragile, a lot of these pluggable wires. So what I've taken to doing is where they mount onto a printed circuit, after I get them soldered in place, I put a little hot melt glue there to hold them on. I have not yet had to do that for the ones that have the slide-on connectors, but when you solder that fine wire in place, you need a strain relief for it. So when you pull on the wires or you're passing it through something, you don't inadvertently pull the wire off the circuit board. Excuse me. And then for modifications, when I'm talking about that is the modifications of any hardware you want to put on. Like one of the things I had to do was to put a little extra support underneath the Raspberry Pi in order to get the SD card to line up correctly to the opening so that I could get the SD card in and out. And I still have to use a pair of needle nose pliers to do that because the 3mm thickness of the box makes it really hard to manage that. And then removal and replacement. I didn't allow for removal and replacement. The way these boards are mounted in my project is I've left tabs sticking up on the columns that support it, and then I hot melt glue it down. And that works fine, except that if you find out you have to change something or you burn something up, you have to then use a soldering iron or something to heat that glue up and remove it again so you can take it back out. So that's some pretty tough lessons there. And just stuff that I wasn't used to dealing with in a plastic structure. All of my main projects for commercial stuff was done either in fiberglass with, I don't know what they call it, they're little embedded nuts, like T-nuts that will hold the screws down. And when you're working with plastic, you can buy those, but I don't have any and I didn't want to spend that money for a prototype. So that's a better solution. Then some things must be very robust. Braces and pivot points. Anytime you're going to support one of these servos or you're going to have something moving, you have to make sure it's strong enough so it doesn't flex. Now those brackets that I showed at the club meeting, they're strong enough. Some of the other things I did initially, I didn't get thick enough or I didn't provide enough support for it. And they would flex and break or wear out too quick and stuff like that. And then I said, well, in prototype, you don't necessarily need to put bearings in. I don't expect this robot to run for years. I expect it to last for maybe a year or a year and a half. And so I'm not really putting bearings on the plastic because I don't think in that whole time I'll probably run it more than 15 or 20 times. We'll see. But if you're going to do it as something you're going to leave and use a long time, you actually need to put bearings in. So what you do in that case is I managed it before. You put a dimple in the plastic big enough to hold the bearing, and you design it so that the bearing can be inserted in, and you can either use super glue or something else to cement the bearing shell in place, and then it will do the job for you. And then the other thing is protect the wiring and motors. Early on, I had one of the servos hooked up to a Arduino, and I was testing it for swing, and I had it running with the 8-volt battery. And of course, the servos are only really rated for 6 volts, and they're supposed to stall out without burning up. But at 8 volts, when they stall out, they burn. So I burnt wiring, I burnt one of the connectors, and I burnt up one of the servos. I always call that the magic smoke escapes, and after the magic smoke escapes, none of this electronic stuff works. Got to keep the magic smoke in there. Control points must also be strong. Servos can break plastic. If servos are stalled too long, they can heat up and burn up, and no magic smoke must escape. So those are some of the tough things. I have a little video here. I'm going to see if this will come up, and you can see how this thing works. Where'd my cursor go? There it went. Oh, come on. Let's see if I can go back. Let's just escape from this, and I'll see if I can start it the other way and get it to come up. Okay, let's see, try it this way. Sorry about this. As I said, I couldn't get an attempt to try this and verify what I had to do to make it all work. Let's see. All of this stuff is part of the files that I've used in creating this thing. Let's see.
All right, Les, your video is showing up on the other screen. Can you move it over to the?
I've moved it. Can you see it now?
There we go. Yep. Perfect. Thank you.
Now, this is full speed of how fast those servos will move. And if you watch this closely, you can still see a little flex in that plastic. See where the arm is here? That's almost 6 millimeters thick. Now, the arm here is swinging. Bicep more or less, and the elbow that are swinging full motion. So there's quite
I'm not hearing audio.
Lesser. We can hear you.
Okay. So what happens, I guess when I run the video, it takes over the audio channel. When the armature's moving, you could see that the top holder of the arm was actually flexing. And that's okay on that because that's not going to be moving that fast normally, but it is a difficult problem to solve. When you talk about something that you want to move, you have to figure out how to support the bearing. One of the things I did there was I added a new bearing support across the top to provide extra support for that. So let me get back to where we were. Then after I got that working, then we have the issues with power distribution. So I currently only have one fuse. It's a master fuse. The batteries are wired together, and then they're wired to the fuse, and then the fuse goes to the MOS switch I'm using to control power. I'm expecting this system to draw roughly 10 to 12 amps in operation. I have 22 servos on there. At this point in time, I may go up to 24 in order to add 26, I guess, altogether, by the time I get a gripper and a wrist action for the gripper. So that's a lot of current, and you've got to be sure you have a way to prevent that from destroying the lithium-ion batteries. They don't do good if you overload them. The lithium-ion batteries I have are good for 30 amps each, and you find that's a part of the rating of the battery. They're actually capable of 3 ampere hours of current, but they can supply an instantaneous current of more than 30 amps. And I know for a fact they don't droop. I checked it. So they were 8.09 volts at 30 amps when they're fully charged. So that's a lot of current. That's 240 watts, and that's just from one bank of the batteries, and there are 2 banks on the robot. You need the ability to turn off the servos with the CPU powered up. I don't have that yet, but most of you have built robots before. You know how advantageous that is in your debugging process. So I'm going to add another MOS switch and put that in the power circuit for the CPU and the other peripherals. Then you need the ability to directly utilize the CPU, because if you're working with a Raspberry Pi like I am, you can set it up for headless configuration, but there are things you can't really do easily from a headless configuration. So one of the problems I have is I didn't allow space for the mini HDMI connectors. So putting the HDMI connectors on right now is impossible. I've got to figure out a way to manage that. They do have right angle connectors available. I've seen them on the internet, so I'm going to see if I can order some that'll work. So that means you need the monitor, and that's why you need the HDMI connector. And peripherals, what I have is I have a one of those little USB Bluetooth keyboards, and that allows me to program it or deal with it headless, with not headless, but once I have a monitor so I can see what's going on. It'll also let me control the robot with like a remote control after I have it running. So I figured that out, and that's going to work all right.
Question?
Yeah.
So if you can't, you said that you riveted down the Pi onto the box.
Yep.
So once you put it in there and that's it, you can't reprogram it anymore, or?
Well, you can reprogram. What I did was I picked the second Pi up. So I have two of these 8 gig Pi 4s, and I can take the board, the SD card out of one and put it in the other one and set up the programming appropriately.
Okay,
But
so you're doing it by switching SD cards.
I'm sorry?
You're doing it by switching SD cards?
Yeah, switching
Okay.
SD card from one to the other.
Hey, I have a question.
Yeah, sorry. Have you tried getting into your Raspberry Pi, through SSH?
Hello?
Using your desktop?
Yes, but there are things you can't do through SSH.
Hey, I have a question.
Yeah.
Okay, my question is why not use VNC? That's what I use for headless, because then I don't have to do SSH or anything. It gives me a desktop. You can turn it on, it's native.
Yeah, I haven't tried that yet. I do have.
You just go in, you turn it on in the Raspberry Pi configuration, just turn it on, then go download the viewer, and you're in.
Oh, okay.
It's real simple. Look it up. There's a bunch of tutorials online. That's what I do.
That'll work because I have another Raspberry Pi right next to it that I use as the programmer for the Arduino, and that would work fine if I can do VNC between the two of them. I'll have to try that. Thank you. That's why I've been sending out those updates. I thought if anybody had suggestions or solutions for some of my problems, maybe I could do better. This is a very complex project. It's a lot bigger than I thought it would be. I probably should have started out with a big robot, then I wouldn't have had half the problems. So now then you run into the issue of how much current and what size wire. So if you're going to run a wire a short distance, you can use a smaller size wire up to a point. Like 22 gauge wire will actually carry 10 amps over a very short distance, like 6 or 8 inches. But if you go 12 amps, that 22 gauge wire will burn up. I'm using a lot of 20 gauge connections for the power, and hopefully that will hold me because I've set the power limit at 10 amps, so I shouldn't go beyond that. But it is something you have to consider, and there you can check the standards to find out what you need to be sure you don't overrun the wire. Then I run into all the 3D printing stuff. So bed leveling, I like printing directly on the glass, and there's a trick you can find to level the bed using 9 circles that you print on the printer bed that are just 1 layer thick, and you judge those circles until you get them to blend and look correct, where the beads are connecting with each other correctly and the circle becomes really solid on the bottom when you peel it off. And it takes a long time. It takes me about 15 or 20 minutes, and running about 4 or 5 iterations of that after I do the basic leveling to get it to set up the way it should be. But once it's like that, the printing is just marvelous, and I print directly on the glass bed. I've never had a print fail when it's set up right. I've had to readjust it twice over the 6-month period, so that's not too difficult to do, even 20 minutes out of 6 months worth of work on that. It's the best trick I found. The speed and layer thickness trade-off. On my printer, I can do 0.1 millimeter at 80 millimeters per second and get good prints. They get a little fuzzy on top, but they're tolerable. At 0.2 millimeter, if I go much faster than about 20 millimeters per second, this print gets sponge-like. It's almost, it's just not usable at all, not even considerable. So you have to make a trade-off, and that will be dependent upon the hot end in your printer. It'll be dependent upon your bed temperature, I'm sure. It'll be dependent on the filament and water content, moisture in the air that day, temperature, all those kinds of things affect it. So you need to kind of characterize the print for your printer. I have 2 printers, so on my other printer at 0.2 millimeters, I can go 40 millimeters per second and everything works. It's just the difference in the hot end. The hot end on my other printer is an EV3D, and I have the 40-watt heating element in it. This is the heating element that came standard with the CR10S, and I think it's 35 watts, so it's a little slower in power. Then when you're doing 3D printing, almost everybody that you do will do with a fill of 20% or 30%, sometimes as much as 40%. But if you're doing mechanical stuff, sometimes you need that solid print in there to allow you to have screws go in or reinforcement for the, like in the servo stuff. And so I have to choose areas where I have to do solid print. And that was a real lesson for me, trying to figure out where that had to be, because I always learned that a good honeycomb structure with solid surfaces on it was pretty solid, but it's actually only about 80% of the strength of solid, and it has 0 compression strength. So if you're going to put a screw through it, honeycomb doesn't cut it. Then mechanical only fittings are best printed in solid plastic. So some of the print software will let you choose where you print solid and where you don't. I don't have that level on mine yet. I know it came with CR10S. I haven't installed that particular version of the slicer. I'm going to have to do that. I didn't discover that mine wouldn't do that until I tried to do it. But I was so deeply invested in this and printing so much stuff, I didn't want to take time to change my slicer, because that will also affect other parameters in your print if you're not careful. So that's a future project, is to upgrade the slicing software. And yours is Cura. So Cura is pretty standard. I don't know what the rest of you are using. There's various slicers out there. I used to use the one that was called Slicer with a 3 for the E, and it worked very well on my other printer. It was better than Cura. So then solid adds weight. That's one of the issues when you're dealing with a robot and you're going to have something swinging out on the end of a servo. That extra weight will add inertia and control power that the servo has to draw off your circuits. So you need to think about where you actually have to have it solid and where you need to be lighter in weight. And I'm just beginning to look at some of those options to see what I can change and make it better. Any questions on that stuff? I think most of you are doing 3D printing, already learned all this stuff. But for me, it was a battle.
I use Simplify 3D, and I've done quite a bit of printing.
Yeah. Is that easier to use, or?
It has a lot more bells and whistles, and it does cost $150, which I went ahead and ponied up the money for.
Well,
it's well worth it for what it can do. Works really well with a variety of printers. Works well with my Airwolf Axiom, and it uses sort of a multi-interface. So you got all these different bells and whistles. Like you can stop it, you can put commands in it. It's a little daunting at first, but they have really good support. So if you want to check it out, you can play with it. There's another one out there, I can't think of the name, but it's similar, and it's free. I'll see if I can post it, maybe get Thomas to put it up for me.
Okay, that'd be great.
Yeah.
One of the other big issues is the distance between points changing. Let's say I was going up here. 3D printing means screw holes have a bit of reduction in size. As you know, the print head makes the circle that you draw in your design, but because the filament comes out and it's going to be wide, it's going to be 0.4 millimeters wide. So you can kind of think of the line you're drawing being in the center of that. So there's about 2 millimeters of bias, 0.2 millimeters of bias on either side of the line.
There's a way to figure that out. You take the diameter of the nozzle, like say you have a 0.4 millimeter nozzle, and that's what it sounds like you're talking about is a 0.4 millimeter nozzle. You take and divide that by 2, and you have to add that to your circle so that you know that you're getting it the right size. It's either add or subtract depending on which way you're going with the print.
Yes.
Steve, is that you?
I eventually figured that out, but I didn't put the number on here because, sorry, I didn't put the number on here because it kind of depends on your nozzle size, because some printers have a 0.35 and some have a 0.4 and some, I've even heard there are a few out there with up to a 0.6 nozzle size on them. So you got to kind of think about it, and that's good that you mentioned this, dividing it by 2 and calculating that into the diameter of the hole you need.
Yeah, there have been hundreds of pages of forum posts and philosophical debate about not only the theory behind why the holes are too small, but if you should account for that or just spec them out as written and just drill them out. Personally, I'll just spec them out to the size they're supposed to be, and then I'll just drill them out to the size I need them to be, knowing that they're always about 0.5 millimeter too small or whatever. But some people will, based on their printer and their slicer, try to account for that with varying degrees of success.
Yeah. So the other things that affect it is the plastic, the nozzle size, the layer thickness, the temperature, and some physical effects of the printing. So depending on your speed, that may affect it too. The distance between points also changes due to plastic shrinking as it cools. That was something I had to learn about too, because I was trying to make mounts, physical mounts for my system. And so I found out that maybe it's about, with PLA plus, it's about 1%. With strict PLA, it's about 1.25%. And it makes a difference if you're trying to get accuracy. So you have to make some test prints and some test fits to check that out. And as you know,
I'm having a hard time hearing.
oh, I'm sorry. Maybe I need to turn my microphone up.
Yeah, it's a little low.
Let's see. It's not going to let me do that without closing everything out.
It was better a minute ago, a couple minutes ago.
See if
I think when you face forward, it catches the audio really good, but when you turn to the side, it loses audio.
Can you hear me better now?
Lower the camera a little bit,
No, not better.
like point straight at you. Okay, try it. Nope. Something happened there.
Let's just go on, because I'd have to get out of all this and figure out how to get back where I am, and I'm not good at that.
Yeah, you're good now.
You're back.
I'll speak up a bit. Okay, so the distance between points will change because of the plastic dimensions. So it's a percentage swell, and it depends on the plastic and temperature and other stuff. So I always did test prints and fitted it out before I did the final run. Then there are run-to-run issues. The printers are plus or minus 1 bit of the resolution. You have plus or minus plastic variability and environmental temperatures, and all of you dealt with all of that. So you kind of have to tune it to what you actually have going on at the time. That's the most frustrating part of it. If you're trying to do real precise stuff, that's really difficult. I finally figured out if I have a bunch of precise stuff, if I set it all up right and make a real quick print of all those pieces, I'm good. And if I don't do it right away, something changes. Then the hollow cylinder effect. I think it was Chris who gave me the hint of using a small bore circle or cylinder inside to produce a more solid cylinder. And that helps. And what I found out was, I did some research on this. So what happens is when you're doing a partial infill, it depends on where the cylinder falls on the infill pattern. So like if the pattern is a square and one line goes through it, you're probably going to be kind of all right. But if the pattern is a diamond and your circle falls in the center of the diamond, like the diamond's around the O on that D, and nothing falls inside, there's not any support. So when you put a smaller, like I did, I used a tower effect where I had a small diameter cylinder on top of a larger diameter cylinder, to hold the printed circuit board up and to position the holes, well, then the top cylinder wasn't held up by anything, and it would just pop off. So that's a skin. So you can talk about the skins and the infill and all of that to make sure you have it solid. And then stringing, you saw with the PET-G. I've used PET-G too, and I don't know. There doesn't seem to be any way to completely eliminate stringing with it. It's really hard. But the PLA, if you get it right, you can avoid all of that stringing. I don't have mine set up quite right now because I think what's happened is my nozzle has changed diameter a little bit because I've been printing so much stuff. There is wear on those nozzles. And
Cura has an ooze shield feature. I know mine does. Slicer, the Simplify 3D has an ooze shield. The ooze shield is supposed to get rid of the strings.
Yeah.
So see if Slicer has a plug-in or something that you can add to it, or create a structure just on the periphery, a couple of mil thick to compensate for the oozing. Whenever it makes a change, the strings happen when it shifts. There's also features where it says don't cross the inner perimeter, and then you won't have your strings in the inside or where you don't want them. That's one way. Now, when you're bridging, bridging is the tricky part because you'll always get strings.
Yeah, and the other part that's hard is when you're doing multiple parts. I've just almost given up the idea of completely eliminating stringing on multiple parts. There's going to be a little bit in between them. It depends a lot on the speed, but I think one of the reasons is I'm printing at fairly high speed. I've got my retraction set to maximum, so that's not the issue. I don't know. There's just a lot to it. There's a lot of variables. But I'm also printing at a fairly high temperature. I'm printing PLA plus at 215. And that's because I found out I couldn't get the structural strength I needed without going that high. Then there's the wiring lessons. Boy, was that fun. I haven't dealt with wiring in probably 25 years. All the stuff I did commercially was done with printed circuits and flex circuit and that kind of stuff. So I had to learn a whole bunch of old lessons that I'd forgotten. Wires have a dimension. It's not just a line on this like it is on the schematic. So it gets thick. You have to pass more wires through. You always misallow the hole sizes. So what I said was holes are never large enough. When you're going to allow a closed structure and you're going to run wires into and out of it, you have to give enough space for extra wires. There's always going to be a change. And what I changed was when I added the extra wires for the screen for the head, that made the hole through the neck have to get bigger. And then when I added the extra wires going down from the power supply and the Raspberry Pi down to control the servo drivers, there's extra wires that have to go there, and power wires and all of that stuff, and it just adds to the diameter. So I kept making the holes what I thought were large enough, and they never were. So now I got big holes and everything works. Then you have the issue of guiding wires in small spaces. Now, most of the time when I had wires I had to guide places when I was working commercially, it was in a false ceiling, and you have those, I don't know if you guys ever used the dart gun with the what we had was like
I've heard of it.
It was a Zebgo reel with a dart gun, and it had the line attached to the dart, and you'd click it like you were going to cast, and then pull the trigger, and it would shoot a nylon line across the room. And that's how you do it in a false ceiling, because you can't really crawl across those ceilings. But in this stuff, something this small, I couldn't figure out a way to do it. And what I finally ended up doing was I'd run a wire through the wrong way that I could get to, and use the connector wires, the jumper wires you use for prototyping, and just connect it to that and pull it back through, and that worked all right. You just have to be real gentle, otherwise it'll pop off, and you end up doing 2 or 3 tries to get it. But it's really, when you got tight holes, that's the process you have to figure out. Then I had the issue with the servo wires, which have the large connector on them, and what I finally just gave up and did was make the hole about 4 times bigger than it needed to be to hold the wire so I could get all the connectors through. just another lesson. Wire ties, people, wire ties. I used to do wiring a long time ago in the Navy on the ships, and we used the old ties. And I don't know if any of you dealt with that. It's a wax thread that you use, and you tie a square knot and pull it tight.
Oh yeah.
Tie a square knot and pull it tight, or an overhand and a loop knot, and sometimes you just bridge it and pull it, you know. Boy, that's hard, but boy, do I love nylon wire ties. So I've used a lot of those to gather the wires into groups, and then I write down my color codes for notes so that I know where to plug them in at the opposite end when I can't see where they started. Then there's the issue of where the wire binds. A robot moves, and in this case where I have the humanoid robot, it moves a lot. As you saw in those arm structures, I used wire ties and tied it down to the structure in places to make sure that the wire was clear of the rubbing and also from being bit down on when the movement would try to pinch it. So it's really hard to think about all of that separately. You have to kind of do that dynamically. And the other thing I finally figured out was how will you strap it down? There are places where I should have left holes to put wire ties on. That's a much easier and cleaner way to do it. When I was in the military, we would just drill a hole in the sheet metal where we needed it and strap the wire down to it. You can't quite do that when you're 3D printing plastic. You need to make a hole so that if you're using a fill, percentage fill, the hole will have some reinforcement around it for something for the wire tie to bite into without distorting the structure. So that's just something to think about. I plan to flex the plastic to mount the servos, and sometimes it works and sometimes it doesn't. I've broken more than one of those pieces and had to reprint it. One of the things that Alan pointed out was using a curved structure instead of a rectangular structure. But if I tried a curved structure, then the structure had to get larger to allow room for the hinging action, and I didn't want to do that. So I just left it rectangular and bent it, and if it broke, I replaced it. But that's a hard way to do it. Another way to do it would be to print the parts in two pieces and bolt them or glue them together around the part you want. And machine screws don't hold in plastic. I've done that a couple of times in order to make it work. But there are special plastic screws. I forgot I was going to look them up and put the place on Amazon you could get those, but I forgot to do it. But you can look up plastic screws on Amazon and they have it. They kind of look like wood, but the threads are a little bigger. There are special ways to make the holes. And one of the things I did on the neck brace was I put a little square area on there with a recess in it and then a hole through it so I could drop a nut in and then put the bolt through the nut. You will see on different structures that they have ways of putting slots in and putting nuts in. That's what I did, and I just ordered a whole bunch of M3 square nuts from Amazon, and I stick those in where I need them. Then there are ways of just adding a nut on top. And then there are special ways to make holes. There are, as some of you may know, there are those inserts that you heat up and you stick them into the plastic. So you make a hole that's slightly smaller than the diameter of the fixture that goes in there. Then there's a thing that looks like a soldering iron, or you could even use a soldering iron, and you heat the piece up and drive it into the plastic. Then the plastic solidifies around it, and you have a brass insert that will take the threaded machine screw and keep it tight inside the plastic. The assembly lessons, where to fasten wire ties, that was a big one. What I finally figured out was with the structure I have and internally, I don't really have a place to tie them, so I just have to fasten the wires together, route them carefully, and when you do a bunch of wires together, they become stiffer. So you can use that stiffness to give them some support and to route them where you want. And if you want to go around the curve, you put a wire tie on both sides, and as you bend them into the curve, the ones on the outside have to go a little further, so then it makes a structure that will kind of hold the curve. You have to watch for binding and grinding, and then you protect the wires. I've used heat shrink in some places to make sure the wires are protected from rubbing. a little bit. Now you got to realize that when you're doing that, you're only providing temporary protection. Even the heat shrink or whatever you use there is going to eventually wear through. So the best way is to route the wire so it's not rubbing at all anywhere. And then there's cooling. So there are two kinds of cooling that you normally use, is active cooling and passive cooling. Most of the stuff I've done here, I've used passive cooling. But for the Raspberry Pi, you need active cooling. So I created a little grill and put it 2 places in the overhead of the cover. So when the cover goes on, it will blow air across the Pi, and then it'll come out on the other side to help keep the Pi cool inside the robot. The unfortunate thing I have now is it doesn't look like I allowed enough space for it to have the fan and the heat sink on top of the Raspberry Pi components. I'll have to verify that. If not, I may have to do yet another print of the body and reinstall everything again. I thought I allowed enough, but not sure. When I actually look at it, it's because it's closed structure, I can't really see it. So I'm going to have to try simulating the heat sink, simulating the thickness of the Raspberry Pi, putting it into OpenSCAD and seeing if the physics work out. And then, of course, where the power converter is, that takes the 8 volts and turns it down to 5 volts to run the Raspberry Pi and peripherals. I wrote the name QB and extracted it from the cover that goes on there so that that acts as an opening for the passive cooling to take place for that. It really doesn't take much. That converter is a switching converter with MOS transistors, and it doesn't really heat up. And then the fan and the vents. That was what I was just talking about. Passive cooling, I just talked about. Temporary structures to simplify debug and setup. So what I did was I breadboarded the whole electronics assembly. I put a piece of plywood down and I glued the battery holders on it. I glued the Raspberry Pi on it. I glued the servo controllers on it and the BN055 and a power switch, and I wired the whole thing up and I tested all of the driver software. So I know that all works. I know it will handle the current up to 10 amps without a problem so far, knock on wood, and that works. So when I got ready to test that arm, the body isn't stable enough, so I added what I call my Dwarf feet. All of you, I don't know how many of you are old enough to remember Tim Conway doing Dwarf, but I used to laugh about that. So I just put little braces that I 3D printed, and they're right here. Let's see if I get that, where my cursor goes, there it is. So if you look right here, there's that brace there. You can see the bolt goes into the reinforcement, which is where the hip joint will go. And they're about 6 inches long on either side of the body. So when that arm was moving back and forth, the body was supported. I'm not sure how the body will be supported in terms of the reaction when this thing is standing up on its legs. So that'll be another place. Maybe my feet will have to get bigger to do that. But at least at this point, this doesn't vibrate at all right now. So that works. So in conclusion, I can say this is a big, small project. By that, I mean the physical size led me to believe it would be pretty short. So when I actually got into it, there are so many details: the wiring, the programming, the testing of the servos, the centering of the servos, all of that stuff. And the design pieces that I did are different from what you would see on most other robots. But I wanted it to be my own and my own unique. And I did it on purpose because I wanted to learn how to do all this stuff. And it's been a neat adventure. I'm really persistent. I always try to tell people when I'm teaching people how to do stuff is you haven't failed till you quit. Well, I haven't quit yet, so I'm not failing. So we'll see how it works. I never touched the software, the mapping, planning, or autonomy. I've got a lot of same obstacles that face the cars. The difference is this robot's not on a plane. Like the software that Walter and the others have used looks with a LiDAR, and that's a plane. And that works all right if your robot's fairly squat. But this robot's going to be tall. It's like the Leap robot. Now, the Leap is pretty cylindrical, and most of the spaces they drive it through are pretty free of small obstacles. But since this robot's going to be moving on feet, and I have to worry about small obstacles and things like the difference between walking on carpet and smooth surfaces, I need to have a more robust navigation and mapping software. So it has to be 3D. I'm not sure how I'm going to do that. I've been doing a lot of research, and right now everybody uses the sending the camera images back to a laptop or a mainframe computer with an array processor and calculating the mapping that way. I really wanted to do it with the Raspberry Pi, but even with the 8 gig Pi, it just doesn't look like it's going to be possible. There's just simply not enough cycles. So that has to be discovered yet. I've already figured out how to calculate the positions of everything based on the fact that with the servos, I have to assume that when I drive the servo, it gets to where I said. I don't have any feedback for the positions of the arms, but I can, by calculation, figure out where the arms are supposed to be, where the feet are supposed to be, where the body's supposed to be, and I have all the angles controlled by the processor. So I should be able to use that and calculate a suspected pose with the correct balance from that, and then do the programming to manage that. The other options that I thought about was putting some control software onto the servos so that I could tell if they were blocked and control the position. I'm still thinking about that. I think there is a neat way to do that. I just haven't come up with it yet. So the grippers have designed, but I finally took the mini gripper and I cut it down to size. Unfortunately, it didn't print. I was hoping to be able to show it today, but the print just didn't turn out. I do have a wrist joint design. I lost one of the pieces here, but I have a little processor, a little washer with a hip on it, and a board with a hole in it, so that will work. And then the other, there's another washer with a point on it, and it has a slot in it for the servo arm, and it'll plug in there, and then that'll pivot the robot around that piece, and I figure out how I want to implement that on the arm. So once I get the mini gripper and that put in place, I should be able to have a hand with a rotating wrist so it can take the right steps. And that's about it, guys. That's where I'm at. I started out thinking I'd do this in 3 months. It's been almost 9 months, and so far I haven't got it working yet, but I'm getting closer. At least I can kind of see the light at the end of the tunnel. The robot will now stand up once I put all the servos in. I can move the arm. I proved that already. I can move all the servos. I proved that already. So it's just a matter of shoehorning it all together and then putting the software to drive it on it.
Is it together right now, Les?
I'm sorry?
Is it in pieces or is it together right now?
It's still in, it's just the body standing up and the arms on it right now. I haven't mounted the legs to it yet because I'm not quite ready to do that. I have to do a bunch more wiring stuff, and I wanted to put the grippers on the arms first so I knew some idea how much inertia that adds to it, because that's going to control what I need for the feet, I think. So I do have platform feet on it right now that are big enough that holds it up nicely. And if necessary, I could just print a larger platform and glue it right to that, and it'll be all right. So I don't think I have to redo all of that structure. I just need to figure out how big it needs to be to work right.
All right. Well, hey, Les, you know what they say? Pixar, it didn't happen. Do you have it near you? Can you show us?
Yeah, I was gonna say, give us a look at it and with your camera.
Okay, let's see what I got here. Let me take my. It's in the other room. Let's see it. I think it's disconnected. I can bring it in.
Yeah, at the Homebrew Robotics Club meeting, they were saying, please, people, remember more on the show and less on the tell. It was kind of funny.
More on the show and less on the tell.
More, yeah. Well, they were for the short presentations that they were recommending please show, more than tell, but, for an
Oh,
hour.
there it is.
Oh, gee.
So this is what it looks
Hey, Alan,
like
how are
now.
you? Oh, yeah, that looks cool.
And
I like that.
the back of it is where all the heavy duty.
Oh, those just standard RC servos on that?
Yeah, they're DS3218s. They're 20 kilograms at 6 volts, and I'm running them at 8 volts. So they have a lot of power.
Oh, boy.
So is that just the torso and the arms?
Yeah,
Ah,
the arms will go this way, and these two pieces, you saw them pivoting in the video.
Mhm.
That gives most of the freedom you need for the arms. And then there will be the mini servo, or the mini gripper will be down to about this length. And then this is where the hips will be, and the legs will be below that. And the legs will make it about probably that tall altogether. You see that?
yeah.
So maybe 25 or 30 inches, and then the head's about 6 inches above that.
Wow.
And so the head, I have a 320 by 240 display, black and white display that'll have the face in it. And I have a little microphone adapter so I can get audio pickup. And I have a speaker. I found these very nice little compact speakers that'll handle 3 watts on Amazon. So I can use a, what do you call that thing? 348, I think it is, LM348. That's a amplifier. So that'll make a 3-watt amplifier. So that's plenty of audio. 3 watts for voice is a lot. Typically with music, you need about 5 watts to get something fairly loud. But with voice, 3 watts is more than enough because you don't have that much bandwidth.
Hey, Les, have you run the torque numbers for how much force you need for the hips and the knees?
No, but well, yeah, I have. It comes out to about 7 inch-pounds at the distance, at the length of the legs.
Uh-huh.
And this whole assembly right now is about 5.5 pounds. So I'm close, but I think it's going to work.
Wait, you said 7 pound-inches?
Yeah, that's at the extremity.
Yeah, yeah.
So, it's 20 kilograms. I'm running about, I figure it's going to be about 30 at 8 volts for these 30 kilogram centimeters.
Mm-hmm.
So that'll come out at 6 inches to be about 7 pounds that it could pick up.
Okay, because yeah, that'll be the challenge for your arms and your ankles. You'll definitely be fine with standard servos. I'm just curious about on the knees and the hips if you'll have enough power to move the way that you need to.
Well, we're going to find out shortly.
All right, that's the spirit.
Some bigger servos, but it's all
Yeah.
so
Yeah, it's going to be fun. Just as a tip, I know this guy that's been clustering Raspberry Pis.
Yeah.
So if you find that you don't have enough power with one 8 gig Raspberry Pi,
Yeah, I thought about that, but then I'd have to extend the body to about. So that's the thought. Anyway, there's a new compute stick coming out from I think it's called Alivio, is the company, and they have I think it's 128 CPUs. The problem is it's the 8-bit version of video software. So I'm not sure how good that would be, but that would probably work out to 5 or 6 meters with reasonable results. So that might work. And I don't know if it would, I don't think I have enough room in here for it, but I could probably put a little cable or a fold back USB connector and put it on there. So anyway, that's where I am right now. So 9 months in, I have a body that actually holds everything. I have the arms working, and you can also see my little brace here at the top that braces the top of these pieces. So what I did was I put a collar up and recessed the screw hole. So I screwed the arms right down onto the servos, and then that collar provides the bearing surface that this guy is pivoting against. So it's supported on 2 points, and that kind of takes some of the stress off of the servos. At least that's what I hope.
Cross fingers.
Oh, yeah, you definitely, this thing has enough power, you don't want to get a finger in the wrong place. It would definitely
Crunch.
hurt your finger. It would probably burst the skin and get blood all over the place. I haven't found that out yet, and I'm hoping I can avoid that. It's not going to be a toy. With this much power on these servos, these guys can do quite a bit of damage. One of them I did once when I was first setting it up, and I didn't have the full brackets made up yet, but I had a kind of a lightweight bracket on it, and it broke solid 1/8 inch plastic bracket completely. It just broke it in half and didn't even slow the servo down. So it was laying there flopping around on the table. So yes, there's quite a bit of power here. And I'm still using my battery holders with what I did was I used I don't know if you can see that or not, but I used a spring from a pin to provide the spring action, and they're in there solid. They don't vibrate or anything. So they're pretty good contact, and I think at about 4 or 5 amps from each one, 4 to 6 amps, it should be all right. In the military, I've used metal contacts like that up to 10 amps without a problem. In fact, we had some of them on some of the batteries in the Navy ran 100 amps. So I think that'll work. They were larger in diameter, but these are pretty good size heads on these screws, so they should be all right. At least so far, they haven't heated up at all that I could tell. And like I said, the one thing I have.
What you're doing is it reminds me of what we did on the Crypt Keeper from Tales to Crypt. That whole bunch of servos, over 40.
One thing that I haven't found yet is a really good solution. I don't know if you can see that or not, but that red thing in there, that's a automobile fuse.
Yeah.
And I chose that.
How much current? What's that rated at?
10 amps. It's a quick plug.
Well, why don't you use the automotive fuses like in your car? You can get the little blocks. You can plug as many different, current channels in there.
Automotive design for exterior use. It's just a single block there, and it mounts down in there, and the fuse just slots into it.
Okay.
I wanted to use a cylindrical fuse with a cylindrical holder that would screw to the plastic, but I couldn't find any that would. What I was looking for was the short ones, because I only need the short size holder to fit in here, and I couldn't find what I wanted. So,
yeah, Les, ghetto pro tip. I don't know if you'd be in favor of this or not, but for some of my smaller designs, I discovered that you can actually solder leads onto the fuse for like a permanent inline type thing if you wanted to forgo the whole.
well, I
Or
thought about that.
you can get some push-on terminals that will fit it too.
Yeah.
I have a quick question.
Sure.
The question is have you looked into the solar panel industry for your connectors and fuses and stuff? Because they have high ratings for a lot of that stuff, because we're talking, your house, which is 120, and that might work. Because I know one guy in the robot club, he has a robot, and that's what he did. He went to a different source other than automotive to get the high current and everything, and it worked out for him.
If you have a bigger robot, that's pretty easy. But most of the solar power stuff is designed for either home use or for boat use. The stuff for marine use is waterproof and really sealed well, but it's a physically large package. The stuff for home use, some of it is okay, but a lot of it is really fragile. It's designed to be stored away someplace where it's not going to be interacted with at all. And I was leery of using something like that inside the robot where it might fall and break. The last thing you want with these lithium-ion batteries is to end up with a short someplace that wasn't intended. because these things will explode. And I didn't have a choice about using lithium because there's no other way I'm going to get the power I need at the weight I need.
Oh, I see.
Hey Les, did you use? I mean, I have had this type of circuit breaker in my robot. It's about 2 inches long. Can you see that?
Yeah, that's what I was looking for, and I couldn't find one like that. And typically they take about a 3/4 inch hole. What's that one take?
Yeah, you ever been to JK Electronics?
This is about that.
Yeah.
They had these at RVAC Electronics in Costa
Well,
Mesa.
also close to my house, JK Electronics carries that stuff too.
Yeah, JK Electronics I heard is very good. I haven't been there.
I've been over to Orvax for a long time.
I also looked into the electronic resettable fuses because they use that in a lot of electronics these days. But the largest current I could find was about 2 amps. And you can't really run them in parallel. You have to put a single circuit in that to be safe.
Yeah, these I bought a 12 amp one of these. These are circuit breakers, so they you know, they just reset.
But for the size, they make the automotive resettable fuses. They fit in the holder you have, and you could solder to those tabs if you wanted to make it even smaller. And that's, I mean, they're just a little bit bigger than the plastic ones, so that's pretty damn tiny.
Yeah. Yeah, if
Ones for the copiers would probably do it too.
I've seen the ones that mount in a 1/4 inch hole, but I couldn't find any when I was looking for them. I looked Amazon, I looked DigiKey, I looked at several of the smaller electronic places, and nobody listed any of them the size that I wanted. I know they exist. I've used them before. I've used them in the production at work. I did find them at one place, but they had to buy 150 of them, and it was like $1,200.
Uh-oh.
I know you guys also build robots, but I don't think we'd ever use 150 of them.
I mean, I've done industrial PLC stuff, so yeah.
You may have to just go
Okay.
into a store to find them.
Yeah, and it's kind of hit or miss. So anyway, that's my presentation. Any other questions? I'll answer anything I can.
Thank you, Les. That was a very nice presentation.
Well, I think it's something that will help a lot of people because all these snags I ran into were just, each one of them would take me a half an hour to an hour to solve, you know. So
Oh yeah, you get really involved.
yeah, it just takes time. So I'm hoping that I'll send the presentation up to Alan, and he can post it, or whoever's posting those things these days, and put it on the web. So tell people at least what to look for and what to expect.
Yeah, once you get a little more progress going and you got them all together and working, maybe you can give us another presentation.
Yep. Oh, one of the other neat things I did, I don't know if you can see this or not, or you can probably see it. This is a piece of ribbon. So what I did was I took silk ribbon, and when I printed the battery holder, I left a hole there wide enough to slide the ribbon through, and then I left a 0.6 millimeter hole all the way through that divider. So what I do is slide the ribbon in, and then I take a piece of wire and push it down through the ribbon and into the bottom, and then cut it off flush. So that holds the ribbon in place. When you want to take the batteries out, you pull on the ribbon and they pop out.
Mm.
So, and without the wire in there, the ribbon comes out. So you don't want to do that. You need the wire in there to hold the ribbon so it doesn't slip out of the slot. That was another lesson learned.
Yeah, I can understand that.
All right. So I think, thank you, Les. And for those that came in late, this is the Robotic Society of Southern California. And I believe Thomas was the first up for show and tell. Thomas?
You're going to have a lot of verbal visual because I'm on phone. I'm outside working.
Who's this?
That was Steve Cook.
Yeah, we have a horse emergency, and I'm doing fence repair while I'm listening in.
Is that you, Steve Cook?
It is.
Yes,
Thomas.
it is. There, Tim.
Okay. Okay. I thought that was your voice.
All right, Mr. Thomas, you're up. But you're muted and you're. Yep, it's you. You're up. But you're mute. You have no audio.
Is he connected? I don't even see him listed.
He's
Oh, there he is.
Maybe we should switch them up, and Jim, if you want to do yours first, and then Thomas after you.
That's fine with me. I mean, let me, if that's okay. So I wanted to show some progress on, I'm trying to finish up this the robotics nano degree program from Udacity this weekend. And I just wanted to show, oh, he's back.
Ah. Da, 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 da.
Can you hear me?
Like Thomas was going in there.
Can you hear me?
We hear you.
Yes.
All right. Well, why don't you finish up? Why don't you finish up and then come back to me?
All right. So yeah, the nano degree program, and it's been going really well. It's definitely an incredible learning experience. Lots of ROS stuff, and what I'd like to show, what I've been working on recently, a part of it is the mapping and SLAM, and let's see, yeah, mapping and SLAM. You can see my screen, I assume now. All right. And so I've created my own, like a model of the my big orange robot, and the 3 levels, and I put it into the ROS world, and it's kind of, it took a bit of effort to get it, to build it, because he just by editing a text file, and it was you know, lots of tweaking numbers to get what I wanted. So this I created my own like build it like a floor plan, which is pretty easy to make actually in a GUI, and that part isn't bad at all. So let me show you this this video I have. Where is it? It's gone. Oh, here it is. Can you all right, can you see the video?
You're sharing your browser.
Yeah, you can never tell what you're sharing here. Okay. Share screen. All right. Okay, so now you see that. I'm gonna max. So I'll play this. So you see my orange robot on the left. On the left is a gazebo. On the right is RViz. And what I've just done, the robot has a it has a LiDAR on it, a simulated LiDAR, and it's got a camera. And on the right side, you're seeing it mapping, just like the real robots we use with the SlamTech map. So this one's all inside ROS, and you can drive. I'm driving it around with a teleop with a keyboard, and you can see how it's building up the map and the walls by just driving around, and it's pretty cool. This is using this RTAB map, or ROS has many built-in or many libraries and nodes that you can use. So this one is a Windows library, a shared object. You can bring it in. Well, it's not Windows. This is all in actually in Linux. So this was run in a Linux simulator or emulator. And so yeah, so that's part of what I'm doing, and just wanted to show the amazing stuff you can do just all in the virtual world, basically. So any questions?
So is that the gazebo and Arviz, are you running that locally on your box, or is that provided virtually as part of the program?
No, yeah. So if you want to see, do I still have it running? So I created a virtual machine with VMware. Well, VMware. So I have a virtual Ubuntu system, and Udacity provides you with they provide you with an image. You can also use they have a online web-based cloud virtual machine you can also use with GPU and everything, but I'm kind of a guy that likes to have everything local, so I opted for the using the actual image and bringing up the VM directly, and that is okay, but it requires more work for you because you've got to remember what you've got to deal with installation issues that maybe they set it up reasonably well, but it's not completely. There might be a little problem here and there that's not that you don't see from the other one, from the web emulator. So like, whoops, if I go back here, if I share, so if you see this is Ubuntu 64-bit, or this is my Ubuntu VMware workstation. So I can run things like ROS launch here, and I assume you're seeing this.
Yep.
It brings up the system, and it runs. I have a decent machine here, but the emulator or the VMware does a pretty good job, and it's definitely reasonable for running all these processes. I do hear my fan ramping up when you've got lots of ROS nodes running, and there's definitely a lot of CPU usage. So here I've launched the teleop, and now I can move the robot around. So this robot, you can see I kind of tried to make it look like my real robot. It's not exactly, but and that blue box there is a camera, and on top is a LiDAR, and so those you configure using various ROS libraries, essentially, or plugins. They're called plugins that simulate these different sensors pretty well, and so they can emulate a full laser LiDAR system and a camera, and you can actually see the camera output. If you actually over in RViz, you can say add a camera. I guess I don't have one here, but you add a camera in, and then you can change the images can be published. As people who are familiar with ROS, ROS is a publish subscribe, and uses that model a lot. So the camera can publish its images, and then they can be viewed or can be absorbed by various plugins, including RViz itself. So here you're seeing the view off the front off of that blue box of the robot driving around, and you can see those little black things on these chair legs. But anyway, so there's a lot you can do in this system, and they teaching me how to do it. Really, it's kind of nice to go through a tutorial essentially that is well written, or pretty well written, and giving you step-by-step instructions. So I think they're still doing the free month. So even if you just want to browse, it's pretty heavy. Getting into ROS is a lot to learn, but they give you these templated files, and it's really not that difficult for most of people. I mean, it's copying, pasting, and following directions. There's C++ programming as well, but you don't even have to. You don't have to do that to get a lot of these benefits. Anyway, so it got me to learn to take a quick, intense course in ROS, which I hadn't been had been putting off for so long. The ROS is cool. It's really not that I have it running on anything here, but I think I will aspire to get it running on a device. I mean, I know Alan has done it for a long time, right?
Oh yeah, I'm excited. We have another ROS convert. I think that makes 2 of us.
Yeah, I have to think. Well, you can even run ROS technically on that SlamTech. I saw there was a port of it, but I don't know if it would be worth doing or better or what. But then their proprietary or their the system they have on there. But at least some in a future robot, I'm definitely using it. Anyway, thank you.
Thanks, Jim. Good stuff.
Yeah, thanks for sharing. That's great.
Yeah. Thomas, are you ready?
Testing. Can you hear me?
Yes, we can. You're not in the view though.
No, I got that little toy in the view.
Oh, you might want to get rid of the background because
yeah, it's making everything invisible.
Yeah, it is.
Okay, hold on. It's not like they just have a button on and off. You have to go through stop video, choose your virtual background, none, close. Okay, so I got a couple things I want to talk about tonight. The first thing is these little tiny robots. They are robots, in fact. They are from Tomy. They're about 20 years old. Some of you might remember these things. I showed them off at the Robot Club about 15 years ago. I picked them up for a couple bucks, and I just found them after not seeing them for 15 years. They got packed away and hidden. These things have voice recognition. Well, sound recognition. They count syllables, actually. They have sensors, a button sensor, a sound sensor. They can communicate with each other.
Oh, Thomas, I have that. I have the Godzilla one and the Snoopy.
Oh, cool. Very cool. Well, they were real popular for a few years, and considering the price of them, you're getting a lot of robotics for the cost of what they were back then. Of course, they don't do nothing compared to modern toys and robots, but this is what cutting edge technology was, 18, 20 years ago.
Yeah, how long ago? That was like more than, 15 years or more.
At least, yeah, I think 2002, 2003 maybe is. Anybody want to do a quick search and tell me?
Yeah, I love that. I actually really was inspired. That kind of, I enjoyed them. They seemed more intelligent than anything at the time, really.
Yeah, they had there's a lot to be said about them. And I just wanted to show them off because I was, a few of you might have seen my niece was in the picture a few minutes ago. I was trying to entertain her while I was watching this since I was her babysitter for that 1 hour. And I was grabbing robots off the shelf left and right trying to keep her quiet. And these were 2 of them that I grabbed for her. Anyway, next up is I know some of you have seen this video, but I'm going to play it now, hopefully share it. It's my first patriotic video. I get patriotic like once a year around 4th of July. It's just a habit here. So I made the video, and then this is Robot Betty 9 singing. Let's see if I can share that video with you. And I'll put the link after you watch it here, so you can, it's probably not going to show up as well. Okay. Okay, let's see if I can share this screen. If I can, I'll ask Alan, because Alan knows everything. Let's see. I've got too many windows open. Share screen. Hey, there's the button. And I'm going to share screen 1. Okay, and click share. And are you seeing? It's not doing anything, is it?
We're looking at Robot's back.
Yeah. Maximize my screen.
Okay, maybe, is that, no, that's not, it's
Play
pointing
button?
at the wrong thing. It says I'm sharing, but it's still looking at the camera. Let me disconnect the camera.
Now we can see your desktop. A lot of folders and files all over it. Thomas, are you there?
Can you hear me?
Now we can.
Can you see anything, any screen?
Yes, the back of Betty 9.
Then we're there, so play it. Hopefully the audio comes through too.
Nope, no audio.
No audio? No audio?
Audio.
Any suggestions, oh great guru?
Maybe
Yes,
do it through your speaker, like play it on your phone or something.
no,
I can turn the volume way up and that might work.
Maybe.
No, when you share your screen, that box that comes up at the very bottom has a little checkbox that
Share
says,
computer sound. I see it now. Thank you, Ben. That's cool.
"You're welcome."
Okay, we try it again. All right then. Can you hear me?
There you are. Yep.
All right. She's ready for the Super Bowl, you know?
Nice.
How do I stop share? I see it. So I'm learning how to use green screen technology. And that's how far I've gotten. It's not perfect, but I'm learning. So Again, as some of you know, I take MIDI files and that's a digitized voice. I digitize the whole thing, putting lyrics into a MIDI file and then running it through a program called Vocaloid. So, any questions? If not, that's it.
All right, looks good, man.
Thanks.
Thanks, Thomas. So there was some talk about that you guys wanted to read the two research papers that came out of Dr. Morales's research that he presented, I think it was like 3 meetings ago. So from the research, he published two papers, which he sent them to me, and he gave us permission to freely distribute them to anybody who wanted them. So I will be posting them to both our website and the Google groups for anybody that's interested in reading them. If you can't get to either one, you might want to send me your email, and I'll email them directly to you. So if there's any other show and tells, I didn't see anything else on the chat.
Maybe I can go.
Say it again, Britt.
Okay. Yeah, I can go. For the show and tell.
You want to do a show and tell?
I guess so.
Go for it.
Because is it like lagging or something?
Right now, you sound fine. When you first came on, it was a little choppy, but you sound good now.
Okay. Yeah, so last week was, or the last time I was here, there was the Barboza presentation on like the vertical farming.
Yeah.
But so I sometimes I do the vertical, well, sometimes I do like the hydroponic farming where it's like slightly automated, because I use the Arrow Gardens, and you can set it up where you can like have its own water and like have its own uh, food supply, and pretty much works for itself. So it helps me learn about the larger vertical farms out there and fully automated systems, and going into space. So I use it to kind of help me learn about it and figure it out. Yeah, there you go.
Cool. Do you have anything that you can show us?
I do have pictures on it, but it would take me a while to find them. So if I was to find them, then I'm on the Meetup page.
Okay.
Yeah, but it's like it has its own. It has water, and then it has like it waters itself pretty much, and but it's
Oh, it looks like we lost audio on you, Brent. Sorry about that.
doesn't even really require like any program. But if you want to do like the lights, then that has settings based on the different plants. And then, but if you won't go to look at the advanced ones for the vertical farms, they have different lights for different plants. And right now, there's a lot of open source going on where they're trying to figure out the different lights for different plants so that others can try it themselves. It's different than conventional farming because it's more it's more open for other people to understand what's going on. It's technological, and Yeah, automated.
Brittany, what was the name of this kind of farming?
It's the one that I use at home. It's by Miracle Grow. It's called Arrow Gardens. Arrowgardens.com. Let's see if I can post this. But it's like one. So if you had a vertical farm, you have to have multiple modules, and they do sell stuff where it's like multiple modules. So you get to figure out how to run multiple systems at the same time. It's kind of like systems engineering in a way. It's kind of cool. I think that, yeah, there you go.
Sounds really cool.
Yeah. But yeah, it's like automated. So it's like robots where you just like type in what
Share your
you,
screen?
huh?
Can you share your screen if you have a picture? Because we can't see anything. We see a black box.
Okay, yeah, I could do that. I could share the screen. And I'll show you which one I use. It's kind of cool. So if I go.
We see it. We see it.
Yeah, this is one where you do the multiple ones and they stack. Because when I first bought them, they don't stack. But these do, and they have like multiple ones now.
Are they computer controlled or are they all manual?
Well, the Arrow Gardens, they are computer controlled. The only part that isn't would be water. I bet even if you did misting, sometimes the misting, if you do, because these are hydroponic, if you do aeroponic, then I think you do need some controls for that. But I've seen drip irrigation where it doesn't really need you know, computer controls. So I bet if you set it up the right way, you could probably go without it. So it's kind of good to know, because like you don't want to have too many things to program and you know, work out and everything. I'll show you the one I have. It's I got it for, some of these are really cheap, and it's like cool to see how the different ones work. And you know, you can always do experiments on plants, but it's this one. Okay, I gotta make sure if it looks the same as the one I have, this one. And I'll show you how it works. It's kind of cool.
Do you have one of these yet at home?
Yeah, this isn't the same one as the one I have. It is called this one though. I don't know, this is a different, these are different buttons than the one I had. They, let's see if I could find it. That one. They changed the buttons on some of these.
Can you show us the real one in your house?
I could take a picture. I just don't have my, I could try. Give me a second to grab it.
Otherwise, next time would be good.
Huh?
Otherwise, next time would be fine.
Yeah, probably next time I'll grab it. It's like hidden somewhere. But I could kind of pull up one that would be the right one. They have a video on how it works for them. Let's see. I think it's hard to find it. This one. Yeah, that one. So it has the buttons where it has the screen. You can look at the different buttons on it and control what it. You control what it does. You control the different settings for each different plant. I don't know why it's not loading. But if you want, I could show you a YouTube video on it while it's loading. Or do they have a I think they have a video on it somewhere. Resources. No, let's do this. My
This is basically
computer's
a
kind of
robotic
slow
plant system. Is
because
that what
it.
you're telling us? Are you saying this is a robotic plant system?
Yeah, because it like does all the it does the gardening on its own, where you there's probably a computer in the garden and you click what you want and the computer sets it up.
That'd be good for me because my plants always die.
It's actually not that bad. The thing is, you always gotta watch out for like the lights overheating and stuff like that. But you could buy the LEDs and you could take out the water basin and move it, and you can grow higher. Because when I have only goes up to a foot, but you can grow higher, and then you have more food than you can ever ask for after a while. And they grow faster than outside in soil and outside. It takes 3 weeks for the plant to get the seed outside, but in the hydroponic garden, it takes the next day. Especially with basil, it's like the greens grow the best with it, like herbs. Ew. Garden. What I like is that it's cheap. It like helps. They have some for kids. It teaches kids like how to how to use them. You know. So they show you how to. They have a few videos. Let's see if they have a short one. Intro.
I was gonna say I use the
Yeah.
grow boxes on the outside in the patio, and they've been great. They're non-technical, but you just put the garden hose in, and the water goes in like a tank to the bottom, and the plant, everything just sucks up the water from below, and everything grows really well. And you only have to water it once every several days.
I kind of looked around and grabbed something so I could show you what I have, because I don't think these YouTube videos are going to show it that well. Let me share my and then I'll stop screen sharing. Here. Okay, so I can't see myself. But yeah, see this? That's the basin, the water. And it goes into a basin. And then it's attached, but yeah, this is how it looks like. I kind of had to take off some of the I have to cover some of the lights down here so it's not too bright, but here's where the LEDs are, and this one doesn't really control, you can't control the different LEDs, but it has red, white, and blue. I'll make the cord larger so I'll plug it in to show how it works. See, like that? This is really bright. It's like that.
That's bright, yeah.
Yeah, it's really bright. And it's hard to cover, but I'll cover it. So you could see this. There's a screen right here. It's hard to see even, but it says the time right now. And so you set the time and it tells you how much nutrients is left, like how many days. And then you press the buttons to tell you what, I'll just say, here, I can turn off. There you go. Okay, so this, I don't think you can even see it even then. But I'll just say what it is, because that'll be easier. So I go to like a menu, press OK. I could set the clock, because it needs to know what time it is. And you decide like, say I use it as like an alarm clock sometimes. The light will turn on and it's like daytime, you know? So you press OK, you go to, you test the pump. There's a water pump, so it kind of filters water automatically. And you set the lights time. You could set the plant flowers, take the least, the least amount of daylight, 15.5, then veggies, salad, herbs, and you could custom. It doesn't really let you custom, it just says 24 hours. And then you go back, and you just say start the garden, and you do. And then here's the, like, what you put the, that's not a good light, but this is what you put the plants in. And you have 6 places, but you could put, like, you could put 4 plants in each one. So you could put like 24 plants in these. It's crazy. And it's, all you do is you put in like, you do 2 steps. You plug it into the wall, you plug it into you put the pump, plug the pump to the base, and then it's set up. So it's like, when I look at it, I learn how plants grow under the light, and because I have time, since I'm not busy watering it and paying attention to all the care of it, I can just see how plants work under artificial light. Yeah.
And you just have to feed it once in a while, right? You put some food in the water.
Yeah, that's the only thing, is nutrients. Because with these gardens, some plants are self-pollinating, so they just like grow on their own. But plants like tomatoes will need bees. But the thing is, you can have mechanical pollinators, and or you could just by hand. And so it like it's like you can take the animals out of the food system, you know, the animals from the soil and the bees, and also anything that might be like competing with the food, like wolves or something.
Or eating it, like the bugs in my garden eat the leaves of the basil.
Exactly. The bugs too.
Cabbage worms, all of them.
Yeah, you don't have any of those issues with the vertical farms. And see, that's the thing about, like, say it's in space. You can have like the plants in space, and they don't really require animals, so you don't need the bees. You don't have to worry about insects. You don't have to worry about soil and the microbes, because some worry, you know, think about nematodes with the soil. They need it to grow, but you don't have to worry about that stuff in space. You just bring the plant and the nutrients, and that's it. And so it's like, it's something viable that can work in space. And so I think about that, because NASA puts some into space too. So it's pretty cool.
Are you possibly working with Bob Barbosa?
Maybe, like, because I don't really use my garden right now. People don't like the lights. And I mean, you can always put like tracing paper to dim the lights, but I was thinking I could just give it to him because he's in Long Beach, which is close. But yeah, because it's cool. It's a learning. It helps you learn. And some of them have like holes in it where you can like see the water level too. And so you can watch on YouTube. Sometimes they have these like really robotic systems where there's a mechanical arm, and it takes seeds from a station and puts it into the ground with soil. Then they take the water. It has a spray nozzle, and it's a water. It's like a robotic arm, and it looks like a 3D printer too, how it's set up. So it's like once you look at these gardens and see how they work and know how they work, kind of makes it easier for you to learn how to do the vertical farms built up. It's kind of like once you learn your first computer program, you can write the programs. Yeah, it's like that. It's a base. So yeah, pretty cool.
It's
Pretty
cool.
cool.
I might have to buy one of those now.
Right?
I'm a garden guy, but it's outside with soil, but this is a whole new thing.
Yeah, and you could just learn how do things in an automated way where you don't need anything that's manual. You don't need to water. You don't need pollinators. You don't need like soil microbes for fertilizer and stuff. It's just like it just works on its own. You just leave it there and you come back and you can eat the food. The only thing is sometimes it takes forever to grow. It takes it'll take a week. I mean, it's actually a lot faster than outdoor farming. As I said, 3 weeks to grow one seed in soil outside. But here, since it's indoors, some vertical farms control the temperature too. It grows, it takes the next day to sprout and then a week for it to grow like an inch. And then after like 60 days or something, some ridiculous amount of time, it goes like crazy up. And then that's when you can start like eating it. But then the issue with these vertical farms is that the roots have no place to go, like when you build the pipes and everything. And so after a while, it gets like no space for the water to get to it. And then it gets like root rot and stuff. And then the one biggest issue with these, if the roots are small, it's fine. But once these roots get big enough, they start to get wood-like, very fibrous, and then the water can't get to it, and then that's when the plant starts dying. But the nice part about vertical farms is its waste is just the plant, so you could bring it outside, you know. But the thing is, with vertical farms, they're thinking about growing, like genetically modifying crops to make smaller roots and larger leaves, because you want to maximize the food that you get from it. So it's like once you start learning about vertical farms, like everything comes into place. And you get to, the more open source you see, the more you look at it, the more you can learn about robotics, like through farming. Yeah, it's pretty crazy.
Hey, Britt.
Mhm.
How long have you had yours?
Well, it's funny. I had one a few years ago, and then my parents put it into water, well, into a container, because it was like the water was spilling, because I had to get it just right, because these water reservoirs work like tanks. They need to be at a certain level to drip the right way, so you need to work out the water levels. But I didn't get it right, so it kept spilling, and then she put it in, and then it like the electronics fried. So then but luckily I was under warranty, so I was able to get another, and then I worked out the water levels just right, and then it works better. The thing is, I guess that if you don't want to work out water levels, you could probably just then you could use like robotics and electronics to pump just the right amount of water, like up or down. Because you have to get it exactly right to the exact level. It's crazy. But it's like they give you enough food that pays for itself, and that's why it kind of works for like space, because it's self-sustaining. And yeah, it lets people just be able to not spend time on agriculture. Yeah, it's pretty
Sounds like
crazy.
fun.
Yeah. So it's like if someone wants to be an astronaut, this is what they'd be eating. Like there was a reference, a movie Disney Channel movie, Xenon, Girl of the 21st Century. Anyone heard about that one?
Yes.
Yes, well, that person, she was saying how in her space station, they ate hydroponic grown food. So it's like kind of the future, you know, that might be what people eat in space one day, because it's automated. And that's what they have in space is like electronics for robots, but they don't have soil and other stuff. And I don't think they want to.
That could be a whole industry, space farming.
Exactly.
Or Mars farming, for that matter.
I think there's like I think if I share my screen, I think there's a video about space farming. I'll show you. Wait, YouTube. Because there's this channel I support because they do talk about science and futurism. Let's see. Space
Brett, I don't want
farming.
to cut you off, but we're running out of time. If it's
Yeah.
a short video, yeah, you can show it, but if
Oh
it's
no, I was just going to show the title of the video and just put the link in. It's not really going further.
Why don't you share it in the group chat so we can look at it later?
Yeah, that's what I'm thinking. But they show how, you know, what agriculture looks like on land, and then they show how it works in space and how we could do it because it's the future.
Okay.
Yeah. So I'll put it into the chat and probably just in there so people can look more into it.
All right. Thanks, Brett.
Yeah, you're welcome.
That's pretty cool stuff.
Thank you.
All right, guys. Does anybody else have any other announcements or show and tells?
If
I
can share
had
my
something,
screen,
but I
I'd
accidentally
like to
blew the
show
processor
something.
up today.
Hold on, Tim.
Looks like Sergey's showing off his vegetables.
That's what you get when you move to Alabama. You know, I have real war with cucumbers. I planted very small patch of them. They are just so aggressive. This is my daily crops.
Oh my God.
I'm hungry.
California.
One day, and I'm not watering them, by the way.
Wow.
Oh, you should pickle them.
Oh yeah, I do. Actually, I had to learn that it's not that difficult.
No.
But you know, guys, I actually wanted to ask a question about ROS 2. We have definitely people here who know ROS and know about ROS, and it's probably a good topic to quickly discuss. Obviously, there is ROS 2 development now in progress, and they just were supposed to come up with a long-term support LTS release. Anybody knows about it? Ellen, maybe you know about it. Could you chime in?
So what I can share with you so far is that in the ROS community, they're almost at a tipping point where they're more aggressively suggesting people start migrating their projects to ROS 2. ROS 2 is fundamentally different. As you had said, I think they've released their last one release, but I haven't converted my Todd framework over to it yet. It's on my list, but it is really different. In some ways better different, but in other ways it seems like more complicated different.
Here's a suggestion. Since we don't have a speaker for next meeting, why don't you give us another one of your awesome ROS tutorials, Alan?
Yeah. Sure.
I certainly
Alan's
won't.
good with those things. He's given quite a few of them.
Yeah.
All right, now I have an excuse to dive back into ROS 2. All right, you got it.
He could.
All right. Yay, we got a speaker for next time.
Yeah.
Hey Tim, didn't you want to say something about that that new humanoid robot you showed me the other day?
Hold on, guys. I think Dalbert, he wanted to say something.
Oh, sorry.
Hey, no worries. I'm from Silicon Valley area and part of the HBRC. And I'm going to just see if I can share my screen.
Welcome.
I've been working on a full-size humanoid for about 10 years. I'm on model 6 right now.
Wow.
Actually, I can share that screen too. Hold on, I can share either screen, I guess. Let's see. Let me know when. Maybe I can share that. Can anybody see that?
Yep, there you go.
Okay,
that's
yeah.
cool looking.
Yeah, that's Karen now. I mean, the head and everything is just kind of for something we did for Maker Faire. This is a. Uh-oh. There. That's a picture of it walking. It's a full size.
You don't have any arms on it yet?
No, well, yeah, let's see. It's got let's see, that's the new arms. There. This model's being retired actually, mostly because, and I'm now working on quasi-direct drives. This is a standard kind of motor that you see, and I'm gonna quit that. This is the standard motors that you see on quadcopters, and they're inside a quasi-direct drive. I don't know if you guys know what that is. I'm gonna try to get back. Oh, stop sharing. There we go.
Yeah, that's okay. That's basically using a brushless motor with a less than, is it 6-to-1 gear reduction?
Correct. And so what happens is it gets zero backlash, which is the biggest problem I've had with my Karen project. Those motors, those big servos, they just have too much backlash. I couldn't afford at the time to try to use harmonic drives and all of the electronics that went with it. I was trying to build something for under $1 million, and you know that anybody can build a full-size Android walking robot for $1 million, but it's not marketable. And Boston Dynamics found that out, right?
So, San Bernardino uses harmonic drives as this animatronic Lincoln head.
Yeah, and harmonic drives are just very expensive, where the quasi-direct drives are relatively inexpensive. You know, so that's what we're working on now. So like I said, the current model has sort of been retired and starting to build from the ground up again. Some of the electronics are the same. The TX2 from NVIDIA is still the same. The camera system's still the same. A lot of the electronics are the same. A lot of them are different. You know, switched to FD-CAN for communications. It's fast. It's, you know, differential bus, so it's nice. And I didn't even know you guys existed. I mean, it's amazing that, you know, nobody at HB Robotics Club ever said anything about you guys. Somebody sent me a link, and I said, "Oh, I gotta check it out." And I think Jim was on. Was it Jim? Were you on at our meeting? You were on our meeting, right?
Yeah.
Yeah.
And I've stopped by the booth at the Maker Faire Bay Area in the past, and I said hello, and I tried to, you know, I gave them my card or whatever, but I was surprised too that although Thomas said he was a member over 12 years ago or 20 years ago.
More than 20.
Yeah.
It's been around for a while.
Because you lived up in the Bay Area.
I lived up in the Bay Area for 15 years, then came down here.
Is that club with Camp Peavy?
Yes, Camp
Peavy, yeah. Actually,
Yeah,
Camp
okay.
is the one who said,
check it out, yeah.
more show and less tell.
Okay, yeah. Yeah, I know Camp.
Camp's a good guy.
Yes. Yeah.
Well, I'm gonna regularly join this once. Is it once a month you guys meet here?
On the second and the fourth Friday of every month.
Okay. It was a rush, and I was kind of. I'm not even at my office right now. That's why I don't have much to show. But as I get the drives working and get them online and get some limbs hooked up to them, I'll show you guys what we're doing and what we're working with. So.
Sounds great.
And now I got to go pick up sushi, and my order's ready, and it's takeout only, as you guys know. So thanks, guys, a lot. I really appreciate it. You guys letting me know that you existed, and it's been fun. So I'll catch you on the next one.
Hey, great having you.
Thank you, man.
Thank you.
Okay. Adios.
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 Tim, were you going to show something?
I was, but I accidentally blew up the board earlier today.
Well, what about that video of that lady who's making that female robot?
I don't have any of it copied down where I could show anybody on my phone. On my computers, yes. My phone, no.
All right. Next,
But
please. Next time.
Okay.
Yeah.
Next time.
Next time.
All right. Well, it sounds like I'm on the hook for a ROS 2 conversion story next meeting. I'll make sure I have that ready for you.
Also, guys, if you want some down the road or something, I do another thing on the Crypt Keeper again. If anybody wants to see that again.
Okay. Yeah. Next time, let's see that.
Yeah, and Alan, you can talk about more practical uses for ROS as well. Or actually, I find it very useful to have examples of any of these systems in use on a robot. It doesn't have to be your robot, but hobby examples of hobby robots running ROS. I know they're out there. It's just that it takes effort to find the link and and get them in front of you. But that's a few mentions of that would be really good, because if you already, I'm sure you already are familiar, because then with that, because then people go, oh, hey, I could use ROS in my hobby robotics. It's not just this. I mean, it's professional. It's used on professional equipment as well, but it works down to the hobby level, right? And that's what we care about mostly.
Yeah, for sure. It's a little bit daunting to get into, as you've seen. So it doesn't solve a lot of the basic programs for like the 101, how do I control a servo? That's not really what the framework's for, but there's a lot of stuff out there. But the moment you want to tie a bunch of programs together that need to communicate and solve a complex task, that's where the ROS framework really shines. So I'll make as much progress as I can in porting the Todd framework over to ROS 2 before our next meeting. And I'll show you how far I get and hopefully how I got there, and some of the differences, for sure.
All right.
Alan, quick question. From your experience, how stable is the ROS 1 now? You've been working with it for a very long time, and you probably experienced every hiccup it has. At the current level, how good is it?
Well, so Howard, stability in what sense? So what are you looking for? Like API stability, or like crashiness?
More or less, yeah, crashiness and that type of thing. I mean, how much pain you experience because there are bugs, there are inconsistencies, incompatibilities, updates break things and stuff like that.
Sure. So one of the challenges of the ROS and the ROS 2 framework is that it's not as well packaged and well documented as, let's say, Microsoft Visual Studio and C# and the things that have millions of dollars behind them. So if you use a supported configuration and you keep your vertical hardware and software stack consistent, meaning you're using a supported version of ROS on a supported version of Ubuntu, and you take a passing interest in when you install update, things are usually pretty stable. Now, that's not to say that every once in a great while I'd run into something where I ran an Ubuntu update and it temporarily broke a little piece of the framework. Just like in Windows, that does happen from time to time. That's why, like for my robots, sometimes they're internet connected and sometimes they're siloed or air gapped, so I don't really have to worry about installing updates all the time. There was one more thing I wanted to share with you about that. So we talked about Ubuntu, Windows, every once in a while something breaking. Because the documentation isn't as amazing as a paid-for product, when you get further deep down into the weeds, occasionally I've found myself where I have to read the source code to know how a certain feature works. And it's just because it's a niche framework still, as cool as it is. You don't have the dozens and hundreds of developers and documenters to exhaustively document all of the APIs and all the functions for all the modules in the node. So that's probably as bad as it gets. Every once in a great while, I'll temporarily mess something up by installing an update that breaks it until someone smarter than me updates that portion of the code. But when I was getting into the nitty gritty, like when I was getting into the ROS remote master and things like that, I was running into things where I actually had to start reading through the source code just to see how to call the function. But in terms of API stability between ROS 1 and ROS 2, the API is stable, meaning that they don't introduce a bunch of breaking changes between versions. So I haven't seen a lot of issues with that. Of course, it's a huge jump to get over to ROS 2, and I've only dabbled with it a little bit. So I guess I have some homework ahead of me before our next meeting.
You're asking about ROS 1, right, Sergey? I mean, ROS 1 is quite stable. Was that your question?
Well, I asked that question, but I got the answer. Exactly what Ellen said was what I expected, kind of to learn.
Yeah, you're for the framework that's built into ROS, I really haven't needed to do any dinking. One of the benefits and curses of ROS is its rich ecosystem of compatible components. Like I always say, you play by the ROS rules, you get to use all the ROS toys in the ROS toy box. Now, if you're lucky and you're using someone else's open source GitHub component that was written for the current version of ROS or is recently updated, then there's a pretty good chance it's going to work. But there's a lot of derelict code out there from previous versions, and you can normally give it a kick in the pants and get the stuff to work, but sometimes you'll find that your programming chops come in handy to kind of dig into the sources and figure out what broke between versions to get it to compile. That's probably the worst that I've seen.
What I've
Thank you.
Drives ROS, because I do better from a book. Is there something like that out there that any of you know about?
There is, right? There's
yeah.
Intro to ROS, the online one for free, right?
Yeah, so here's what I'll do. I'll post in the chat a link to an open source text. It's called A Gentle Introduction to ROS. It's the kind of book that you want to read cover to cover and then read it once or twice more cover to cover, because it tells you a story of how all the pieces fit together. And it has some examples, some exercises you can try. And at the end of that book, it puts you in a better position for a deeper dive into some of the more advanced texts that read more like a dictionary. But I'll put a link in the chat. It's a great place to start.
I started with ROS 1. I got up to the point where it was ready to introduce the SLAM navigation. And the link they had was no longer valid. And what I printed out doesn't really work. So I kind of put that aside to go ahead and finish the physical stuff on my robot. But I was planning on using ROS to drive it, because I know I can create all my own software. I really can. I just don't know how long it would take me to do that. So if I have a core that handles all the message passing, then I can concentrate on just the pieces I need to drive and hooking them up. So it's frustrating to me at this point.
As a ROS beginner, actually, I found that reproducing Turtlebot and making it map the room and actually go to the point that you click on the map is the most kind of not the easy, but most useful and hands-on experience.
Yeah, and it's one of those things where you can read the book and you can go through the exercises, but until you have a problem to solve, a lot of the stuff that you're trying to absorb won't make sense. So your robot is a great application for the ROS and the ROS 2 framework, and it would be a great opportunity to get started, from the ground up, loading up ROS into that version of Ubuntu, finding, the simple move the servo type things, and how you're going to get your Raspberry Pi. I'm assuming you're using like a 16-channel turbo driver or something to interface with the Pi over I2C. Oh, sorry, Les. I guess you're on mute. Oh, sorry about that. Yeah, you're still muting. But yeah, like I'll make this offer to everyone, and I think a lot of our club members are the same. I'm not really an expert in anything, but I dabble. If at any point in time you think I can help with anything that you're working on or have some questions, just reach out to me or start a post on Google Groups. I'm happy to share anything I picked up that would be helpful to you. For sure.
There were some like last minute things I wanted to say about the garden, if that's okay.
We're running a little bit late, but pretty quick, sure.
Yeah, it's just really quick. Like I remember that microgreens, which is why it's popular for like space stuff, that doesn't really require fertilizer, but you have to get the seeds from somewhere. So you only need one plant to like grow to get the seeds, and that's the one you have the fertilizer for. But the rest of it, you don't really need it because microgreens grow. It uses nutrients in the seed. And also I found the videos that are like really short. They're like 10 seconds each, if that's okay. So this one shows like how like it's like its own bee, you know? So it's like that. So there's that one, and it shows like in soil. I'll go to the beginning. And so that's the thing. It's like everything's like mechanical. So it's like with water, it's a lot faster because it doesn't have to fight the soil for the roots. The roots don't have to fight the soil to get water and nutrients and stuff. That was the setup. This one shows you like the robotic part. You can see there's like a computer here.
Brett, can I stop you there?
Yeah.
How about you just put together a short presentation and give it to us all next time?
Well, that was pretty much it. So yeah, that was it. But yeah, it shows you there's a water pump, and that's pretty much it. Yeah.
Okay, because
There you go.
we are running late.
Yeah.
Thank you for sharing.
Yeah.
Very
Thanks.
cool.
All right, guys. If there's any other questions.
I'm sorry, what did you say, Ben?
Alan, you were going to post a link for that book.
He did.
He did?
Oh, you did?
He did.
Oh.
It's there.
In the chat.
Hey, Walter, how are you?
Oh, okay, thanks.
I need to call you later. I got some questions about the computer. I got some stuff programs accidentally loaded, and I can't get rid of them.
All right, so it looks like we're going to wrap up. Looking at the calendar, our next meeting is on July 10th.
Yes.
Okay.
All right, glad to see everyone's doing well. Have a great night and a great weekend, and we'll catch up in a few weeks.
Good night, everybody.
Thank you all.
Thanks, everyone.
Yeah.
Thank
Nice
you.
presentations. Thank you.
Good meet.
Good one. Stay safe.
Bye, guys.
Yeah, you too.
Good night.